I call them hash maps, but they're dictionaries in Python. If dig is not, if it's in all of these, for every digit, that means you can't put that digit in the board. So there's no, you basically end up in a situation, a DFS path where you're stuck, right? You're stuck whenever you're kind of like going through the board here and you add a number, but you no longer can add a number because of numbers you've done before, so you have to backtrack. So the backtrack, if DFS returns false, that's when I'll backtrack. To backtrack, you just want to do reset this to empty. So basically undo everything you just did. So there's a function called discard, which allows you to remove something without getting the key error. So it's kind of handy. I kind of learned it doing this problem. And discard this one. Okay, so at this point, I think we did everything. We just need a base case if basically if the empty, if it's not empty, I think we want to return true. That means we've like, you know, there's nothing we're even gonna add to this table, and I'm assuming that is partially filled, I guess. So there's one thing that I feel like is assumed in this solving it this way, which is you're kind of let's just run tests, see if it works. Okay. Well, yeah, I guess I forgot to do anything with my empty. That's right. So I need to do empty dot pop left, and then here empty dot append left RC. Okay. Okay, yeah, so I forgot to remove from my list of cells. Now if I remove from my list of cells and it contain like coordinates, and then, you know, if I'm backtracking, I append it back on and I append it in front. So then we're going to try a different digit and then we're going to go down the path again. So if I do a run through or an explanation of this code, it's DFS plus backtrack, and this first part here is just creating the a hash map of rows to the values, a set of the values that are already seen. We do it for columns and we do it for the subboards. And anything which is anything that's like an R or anything that is already empty, we add it to our deck, our double-ended queue for empty. That way, we can, if we go through here, the DFS, we're going to go through our empty thing and try to add stuff from it. So we look at our row and our column for our first empty, get the coordinates of its cell where it's empty, or yeah. And then iterate through the digits from 1 to 9. Find any digits that is not contained in all of these. Basically, a digit that I can actually use to solve it. If I can use it to solve it, you know, do this stuff, and then empty pop left, and then if DFS return true. So then this is the recursion, so it just keeps calling, keep calling. eventually it may get to a digit that cannot be used in any of these, and it sees, well, hey, it's going to return false, and since it returns false here, it's going to go down here, and it's going to have to, by the way, the reason why I didn't include an else statement here is because I have a return here. So like it's only going to run this if this ends up being false, if it doesn't run this if statement. So if it doesn't run the if statement, then it's going to go backtrack and discard everything we've done and append back to the empty. And then it's going to iterate to the next digit, try another digit, and then do DFS search from that digit. So it's basically just like, it's kind of like a greedy algorithm, isn't it? Like it's not greedy because it's not necessarily choosing what's locally optimal, but it's just going in order of digits and choosing a digit, doing a DFS search with that digit, and then it has to backtrack if it gets stuck, and then once it backtracks, it tries another digit, and then but it'll keep doing that process over and over, searching down a path, and then backtracking when it gets stuck, and so on. Yeah. So I think that took me pretty long, so I'll end it right there.